Hello friends, welcome back to my channel, that is online class with Silva. So friends, today's topic is Krebs cycle, which I will explain you in the next video. So let's get into this video.
Krebs cycle is also known as TCA cycle, and it is used to generate energy through oxidation of acetyl coenzyme A. So it helps in synthesis of NADH, production of amino acids, and it takes place in the mitochondria of eukaryotic cell or eukaryotes and the cytosol of prokaryotes. It has converted into two stages. The first stage of glucose to acetyl coenzyme is known as the preparatory phase, and the second stage is whole Krebs cycle stages, or you can say the whole Krebs cycles. In the first step, which is involved, is actually preparatory phase or step, which begins with the pyruvate. Pyruvate is derived through the glycolysis of glucose, which is actually 6 carbon, and split it into two molecules of pyruvate, which is 3 carbon. In the next step, it includes the oxidation of pyruvate into acetyl coenzyme A by the enzyme pyruvate dehydrogenase complex, and in this reaction the molecule of carbon dioxide and molecule of NADH is generated, and the acetyl coenzyme is formed with two carbon compound. Here the pyruvate is converted into acetyl coenzyme A by the enzyme pyruvate dehydrogenase complex. Along with it produced carbon dioxide and NADH. In the next step, acetyl coenzyme A combined with oxaloacetate, which has a 4 carbon compound, to form citrate, which has a 6 carbon compound. This reaction is catalyzed by the enzyme citrate synthase. In the next step, the citrate is formed or isomerized into isocitrate by the enzyme aconitase. Next, the isocitrate is oxidized into alpha ketoglutarate by the enzyme isocitrate dehydrogenase. Here the isocitrate, which has 6 carbon compound, is converted into alpha ketoglutarate, which has 5 carbon compound, by the help of isocitrate dehydrogenase enzyme. Along with it, the NAD molecule is converted into NADH, and carbon dioxide also released. Here NAD is reduced into NADH, and one molecule of carbon dioxide is also formed. Hence, the alpha ketoglutarate is a 5 carbon compound. Since one molecule of carbon is lost into carbon dioxide, next the alpha ketoglutarate is converted into succinyl coenzyme A by the enzyme alpha ketoglutarate dehydrogenase. By the help of alpha ketoglutarate dehydrogenase, alpha ketoglutarate converted into succinyl coenzyme A by the help of alpha ketoglutarate dehydrogenase. And in this reaction also, one molecule of NAD is reduced to NADH, and one molecule of carbon dioxide also released. And next, the succinyl coenzyme A, which has a 4 carbon compound, is converted into succinate by the enzyme succinyl coenzyme A synthetase. Here the succinyl coenzyme A converted into succinate by the help of succinyl coenzyme A synthetase. Along with that, in this reaction, a molecule of GTP is released. Here GTP is released. Okay, next is your succinate, which is again converted into fumarate. Here succinate is converted into fumarate by the help of enzyme succinate dehydrogenase. Is the 7th number reaction, where the succinate is converted into fumarate by the help of succinate dehydrogenase, and here FAD reduced FADH2. In this reaction, a molecule of QH2 is generated, which is also used for the production of FADH2. Fumarate is then converted into malate by the enzyme fumarase. Here the 8th number reaction, where the fumarate is again converted into malate by the enzyme fumarase. Okay, next ninth number reaction is malate. After release of malate is again converted into oxaloacetate, which is 4 carbon compound. By the help of malate dehydrogenase, malate converted into oxaloacetate. In this reaction also NAD is converted to NADS2. Okay, and again next the oxaloacetate is converted into citrate by the help of citrate synthase along with the addition of acetyl coenzyme A and oxaloacetate both added to form citrate by the enzyme citrate synthase. It converted from acetyl coenzyme to citrate by the help of citrate synthase. Oxaloacetate converted into citrate. The question is results. What are the results of the Krebs cycle? Okay, now look. Uh, Through each cycle of Krebs cycle, the following products will be generated, like your 3 NADH. I will be right here. Okay, the result. What would be the result? Here 3 NADH, 1 FADH2, 1 GTP, 1 carbon dioxide. These will be, these are the product, these are the production of Krebs cycle. But as it goes through, as one glucose molecule is metabolized to form how many number of ATP produced. Here the question is how many number of ATP produced by the Krebs cycle. I will be explain here. See, all the steps converted from glucose to pyruvate to citrate, isocitrate, alpha ketoglutarate. In this citric acid cycle, there are a series of redox, dehydration, hydration, and decarboxylation reactions forms. And each turn of the cycle forms one GTP or ATP as well as 3 NADH molecules and 1 FADH2 molecule, which will be used for the further steps of cellular respiration to produce ATP for the cell. Okay. So, how many number of ATP produced in each cycle, or the total number of ATP produced in the DC cycle, I will explain you in the next class. Till then, let me tell you how to remember each and every cycle along with the enzymes in short form, so that it will be easy for you to remember all the steps along with all the enzymes and production. So now let me explain you each and everything. See, here you got 3 NADH, 1 FADH2, 1 GTP and 1 carbon dioxide. Okay, which goes to electron transport chain, which produces ATP. So I'll explain you ETC cycle, then I will tell you what are the number of ATPs produces from each cell. So I was talking about how to remember all the steps. Let me write here. Can I keep selling okay, can I keep selling substances for money, officer? You have to remember these sentences which I'm talking right now, so that it will be easy for you to remember all each and everything, every steps along with the enzymes. So here can means citrate, I means isocitrate. Keep means alpha ketoglutarate. Selling means succinyl coenzyme A. Substances means succinate. F for means fumarate. M means malate. Malate. O means oxaloacetate. So remember this way. Can I keep selling substances for money, officer? Can for citrate, I for isocitrate, keep means alpha ketoglutarate. Selling means succinyl coenzyme A, substances means succinate, for means fumarate, money means malate, O means oxaloacetate. Okay. Remember all this way. Next is your this is all about the cycle, and next is your enzymes name. How to remember all the enzyme name? So okay. So at a disco, they've sipped down 5 drinks. So means synthage. At means aconitage. Disco means isocitrate. Dehydrogenase. They've alpha keto glutarate dehydrogenase. Sipped means succinyl coenzyme A, synthage. Okay. Down means succinyl dehydrogenase. 5 means fumarase. Okay. So for synthase, at means aconitage, disco means isocitrate dehydrogenase, dev means alpha ketoglutarate dehydrogenase, sipped means coenzyme synthase, down means succinyl dehydrogenase, 5 means fumarase. So remember this way. I mean, you have to remember the sentences so that you can easily remember the enzyme also. So if this is hard for you to remember, I will tell you the next few sentence so that you can easily remember this cycle. So here is the next one. Of course, citrate is a silly, stupid, funny molecule. Okay. Of course means oxaloacetate. Citrate means, as usual, citrate. Is means isocitrate. A means alpha keto glutarate. Silly means succinyl coenzyme A. Stupid means succinate. Funny means fumarate. Molecules malate. So this is all about the cycle name. Of course means oxaloacetate, citrate means citrate, is means isocitrate, A means alpha ketoglutarate, silly means succinyl coenzyme A, stupid means succinate, funny means fumarate, molecule means malate. So next one I also have to remember. Okay. Can intelligent Krebs solve some forensic murder operations? Okay. So can means here SIG stands for citrate or citric acid. Intelligent I stands for isocitrate. Krebs stands for keto. Alpha keto glutarate. Okay. Sulf S stands for succinyl coenzyme A. Some S stands for succinate. F stands for forensic. F stands for fumarate. Okay. Next is your murder. M stands for malate as well. Next is your operation stands for O for oxalo acetate or oxalo acidic acid. Okay. Can intelligent Krebs solve some forensic murder operations? Can for citrate, intelligent for isocitrate, Krebs for alpha ketoglutarate, solve for succinyl coenzyme A, some for succinate, forensic fumarate, murder malate, operations oxaloacetate or oxaloacidic acid. Okay. Now let me tell you what are the steps for Krebs cycle. The first one, Krebs cycle steps. Okay, remember in this way: CD, rod, OD, POHO. CD, rod, OD, POHO. In the Krebs cycle, there are 10 steps: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, okay, 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, here, sorry, CD, OD for number 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. This OD whole is 6. Then 7, 8, 9, 10. Okay. Number 1 is C. Number 2 is D. Number 3 is R. Number 4 is O. Number 5 is D. Number 6 is OD. Number 7 is P. Number 8 is O. Number 9 is H. Number 10 is O. C stands for condensation. Condensation. Number 1 reaction is condensation. That means addition of water. Addition of water is known as condensation reaction. Then second one is dehydration. D stands for dehydration. This means the removal of water. Okay. Then third one is rehydration. Rehydration means addition of water. Then fourth one is O stands for oxidation. That means like NAD is converted to NADS2 is oxidation reactions. Then D is decarboxylation. Decarboxylation. Okay, that means removal of carbon dioxide. Removal of carbon dioxide is known as decarboxylation. Okay, next one is OD. OD means oxidative decarboxylation. That means, for example, NAD to NADH2 means removal of carbon dioxide. Then P for phosphorylation means GDP plus PI converted to GTP. Number 8, oxidation, where addition of oxidation, here the FAD to FADS2 is oxidation. Next is your hydration, means addition of H2O, water. Next is oxidation, like this, NAD converted to NADS2 in the 10th number reaction. So all those 10 steps along with the reaction name CD ROD OD POHO, CD rod OD POHO, CD rod OD POHO, C for condensation, D for dehydration, R for rehydration, O for oxidation, D for decarboxylation, OD for oxidative decarboxylation, P for phosphorylation, O for oxidation, O for oxidation, H for hydration, O for again oxidation. So these are the chemical reaction along with their name. What does this reaction means? So try to remember like this way, CD rod OD POHO, so that you can easily remember all the steps. Next is your how to remember all the structure of the reaction, like acetyl coenzyme A, citrate, isocitrate, alpha ketoglutarate. What are their structures? This is not actually mandatory to write in your answer paper in any long questions, or else you have to just remember for the entrance basis questions, so that you can easily remember all the structure, what happens along with their structure. So I will explain you here. Okay, the first one is acetyl coenzyme A. Okay, acetyl coenzyme A, the structure would be CH3 C double one O SCOA C2. This is the structure of acetyl coenzyme A. Next is your citrate. CCO minus OH CCH2 CO minus CH2 COO minus. Okay, citrate is 6 carbon, C2 2 carbon, 1 2 3 4 5 6. Citrate 6 carbon isocitrate. Next is isocitrate which is also 6 carbon. The structure is CHCOO minus CH2 COO minus CHOH COO minus. Next is your alpha keto glutarate, and the structure it's 5 carbon. The structure is CS2 CS2 COO minus C double one O COO minus. Next is your succinyl coenzyme A C4 is CH2 COO minus C double one O SCOA. Next is your succinate. The structure of succinate is it's 4 carbon. It's CS2 CH2 COO minus CS2 CS2 COO minus COO minus CS2 CS2 CO minus CO minus. Your fumarate is CH C double one O minus C double one O minus. It's so easy to remember, like CS2 CO minus CH CO minus CO minus. Next is your oxaloacetate. This is also 4 carbon. This is also 4 carbon. The structure is, is here CHOH CS2 COO minus COO minus. So these are the structure of all the cycle, like your acetyl coenzyme A, from acetyl coenzyme A to oxaloacetate. The name of each and everything I have written here. So try to practice every day so that you can easily remember, and you can make you can prepare a chart size paper. You can write down all and everything in a paper, A4 size paper. It's better to paste sticking on your wall, stick on your wall. Okay, now this is finished. You can write down each and everything along with the cycle in a A4 size paper and stick on your wallpaper, so that it's easy to remember each and everything. So yes, this is all about Krebs cycle. Hope you all enjoyed this video. If you like this video, what you need to do like, share and subscribe to my channel. Comment below if you have any doubt. So what would be the next class? I will explain you the ETC cycle in the next video, and the glycolysis also. So in the next video I will explain you glycolysis and the ETC cycle. So till then, take care. Bye bye.
Thank you for watching this video.